water in an inexpensive process, you'd have enough fuel for the entire lifetime of the rest of the planet. So, it's got lots of challenges ahead, but it is an example of the many hundreds and hundreds of ideas that we need to move forward. So let's think, how should we measure ourselves? What should our report card look like? Well, let's go out to where we really need to get and then look at the intermediate. For 2050, you've heard many people talk about this 80% reduction. That really is very important that we get there. And that 20% will be used up by things going on in poor countries, still some agriculture. Hopefully we will have cleaned up forestry, cement. So to get to that 80%, the developed countries, including countries like China, will have had to switch their electricity generation altogether. So the other grade is, are we deploying this zero-emission technology? Have we deployed it in all the developed countries, and we're in the process of getting it out elsewhere? That's super important. That's a key element of making that report card. So backing up from there, what should the 2020 report card look like? Well, it should have the two elements. We should go through these efficiency measures to start getting reductions. The less we emit, the less that sum will be of CO2, and therefore the less the temperature. But in some ways, the grade we get there, doing things that don't get us all the way to the big reductions, is only equally or maybe even slightly less important than the other, which is the pace of innovation on these breakthroughs. These breakthroughs, we need to move those at full speed. And we can measure that in terms of companies, pilot projects, regulatory things that have been changed. There's a lot of great books that have been written about this. The Al Gore book, Our Choice, and the David Mackay book, Sustainable Energy Without the Hot Air. They really go through it and I think can create a framework that this can be discussed broadly, because we need broad backing for this. There's a lot that has to come together. So this is a wish. It's a very concrete wish that we invent this technology. If you gave me only one wish for the next 50 years, I can pick who's president, I can pick a vaccine, which is something I love, or I could pick that this thing that's half the cost with no CO2 gets invented. This is the wish I would pick. This is the one with the greatest impact. If we don't get this wish, the division between the people who think short-term and long-term will be terrible, between the US and China, between poor countries and rich, and most of all, the lives of those 2 billion will be far worse. So what do we have to do? What am I appealing to you to step forward and drive? We need to go for more research funding. When countries get together at places like Copenhagen, they shouldn't just discuss the CO2, they should discuss this innovation agenda, and you'd be stunned at the ridiculously low levels of spending on these innovative approaches. We do need the market incentives, CO2 tax, cap and trade, something that gets that price signal out there. We need to get the message out. We need to have this dialogue be a more rational, more understandable dialogue, including the steps that the government takes. This is an important wish, but it is one I think we can achieve. Thank you. Thank you.
Thank you. Thank you. So, thank you. Just to understand more about Terrapower, right? First of all, can you give a sense of what sort of scale of investment this is?
Well, to actually do this software, buy the supercomputer, hire all the great scientists, which we've done, that's only tens of millions. And even once we test our materials out in a Russian reactor to make sure that our materials work properly, then you'll only be up in hundreds of millions. The tough thing is building the pilot reactor, finding the several billion, finding the regulator, the location that will actually build the first one of these. Once you get the first one built, if it works as advertised, then it's just clear as day, because the economics, the energy density are so different than nuclear as we know it.
And so to understand it right, this involves building deep into the ground, almost like a vertical kind of column of nuclear fuel, of this sort of spent uranium. And then the process starts at the top and kind of works down?
That's right. Today, you're always refueling the reactor. So you have lots of people and lots of controls that can go wrong. That thing where you're opening it up and moving things in and out, that's not good. So if you have very, very cheap fuel, then you can put 60 years in, just think of it as a log, put it down, and not have those same complexities. And it just sits there and burns for the 60 years, and then it's done.
It's a nuclear power plant that is its own waste disposal solution.
Yeah, well, what happens with the waste, you can let it sit there. There's a lot less waste under this approach. Then you can actually take that and put it into another one and burn that. And we start out actually by taking the waste that exists today that's sitting in these cooling pools or dry casking by reactors. That's our fuel to begin with. So the thing that's been a problem from those reactors is actually what gets fed into ours. And you're reducing the volume of the waste quite dramatically as you're going through this process.
I mean, you're talking to different people around the world about the possibilities here. Where is their most interest in actually doing something with this?
Well, we haven't picked a particular place, but and there's all these interesting disclosure rules about anything that's called nuclear. So we've got a lot of interest that people from the company have been in Russia, India, China. I've been back seeing the Secretary of Energy here talking about how this fits into the energy agenda. So I'm optimistic. The French and Japanese have done some work. This is a variant on something that has been done. It's an important advance, but it's like a fast reactor, and a lot of countries have built them. So anybody who's done a fast reactor is a candidate to be where the first one gets built.
So in your mind, timescale and likelihood of actually taking something like this live?
Well, we need, for one of these high-scale electrical generation things that's very cheap, we have 20 years to invent and then 20 years to deploy. That's sort of the deadline that the environmental models have shown us that we have to meet. And Terrapower, if things go well, which is wishing for a lot, could easily meet that. And there are, fortunately now, dozens of companies, we need it to be hundreds, who likewise, if their science goes well, if the funding for their pilot plants goes well, that they can compete for this. And it's best if multiple succeed, because then you can use a mix of these things. We certainly need one to succeed.
I mean, in terms of big-scale possible game changers, this is the biggest that you're aware of out there?
An energy breakthrough is the most important thing. It would have been even without the environmental constraint, but the environmental constraint just makes that so much greater. In the nuclear space, there are other innovators. We don't know their work as well as we know this one, but the modular people, that's a different approach. There's a liquid-type reactor, which seems a little hard, but maybe they say that about us. And so there are different ones, but the beauty of this is a molecule of uranium has 1 million times as much energy as a molecule of, say, coal. And so if you can deal with the negatives, which are essentially the radiation, the footprint and cost, the potential in terms of effect on land and various things is almost in a class of its own.
If this doesn't work, then what? Do we have to start taking emergency measures to try and keep the temperature of the Earth stable?
Yeah, if you get into that situation, it's like if you've been overeating and you're about to have a heart attack, then where do you go? You may need heart surgery or something. There is a line of research on what's called geoengineering, which are various techniques that would delay the heating to buy us 20 or 30 years to get our act together. Now, you hope, that's just an insurance policy, you hope you don't need to do that. Some people say you shouldn't even work on the insurance policy because it might make you lazy that you'll keep eating because you know heart surgery will be there to save you. I'm not sure that's wise given the importance of the problem, but there's now the geoengineering discussion about should that be in the back pocket in case things happen faster or this innovation goes a lot slower than we expect.
Climate skeptics, if you had a sentence or two to say to them, how might you persuade them that they're wrong?
Well, unfortunately, the skeptics come in different camps. I mean, the ones who make scientific arguments are very few. You know, are they saying that there's negative feedback effects that have to do with clouds that offset things? There are very, very few things that they can even say, you know, there's a chance in a million of those things. The main problem you have here, it's kind of like AIDS. You make the mistake now and you pay for it a lot later. And so when you have all sorts of urgent problems, the idea of taking pain now that has to do with the gain later, and a somewhat uncertain pain thing. In fact, the IPCC report, you know, that's not necessarily the worst case. And there are people in the rich world who look at IPCC and say, okay, you know, that isn't that big of a deal. The fact is, it's that uncertain part that should move us towards this. But my dream here is that if you can make it economic and meet the CO2 constraint, then the skeptics say, okay, I don't care that it doesn't put out CO2. I kind of wish it did put out CO2, but I guess I'll accept it because it's cheaper than what's come before.
So that would be your response to the Bjorn Lomborg argument, that basically if you spend all this energy trying to solve the CO2 problem, it's going to take away all your other goals of trying to rid the world of poverty and malaria and so forth. It's a stupid waste of the Earth's resources to put money towards that when there are better things we can do.
Yeah, well, the actual spending on the R&D piece, you know, say the U.S. should spend $10 billion a year more than it is right now. It's not that dramatic. It shouldn't take away from other things. The thing you get into big money on, and this reasonable people can disagree, is when you have something that's non-economic and you're trying to fund that. That, to me, mostly is a waste. Unless you're very close and you're just funding the learning curve and it's going to get very cheap, I believe we should try, you know, more things that have a potential to be far less expensive. If the trade-off you get into is let's make energy super expensive, then the rich can afford that. I mean, all of us here could pay 5 times as much for our energy and not change our lifestyle. The disaster is for that $2 billion. And even Lomborg has changed. His shtick now is, why isn't the R&D getting more discussed? He's still, because of his earlier stuff, sort of associated with the skeptic camp, but he's realized that's a pretty lonely camp. And so he's making the R&D point. And so there is a thread of something that I think is appropriate. The R&D piece, it's crazy how little it's funded.
Well, Bill, I suspect I speak on behalf of most people here to say I really hope your wish comes true. Thank you so much.
Thank you. Okay.
My name is Sonia Nuttall from the Evans Zen Foundation. How does change happen? You raise the awareness and you inspire the change. You come to TED, you do TEDx, and you build a community, and you find solutions. And at Urban Zen, that's what we do, and that's why we come to TED. Thank you.
People are playing with words. Yeah, it's true. All week long, people have been putting words together in very unique ways. I've been thinking about how food and wine are paired by experts who really understand the flavors. And here at TED, people are putting words together in pairs because they understand the meaning. Reckless creativity. What a pairing that is. Just thinking about words that don't go together, where 1 and 1 equal 3. I think that's what TED's all about, isn't it? It's just putting things together we don't normally think of.